Hi, welcome again to this video for another example of a separable equation. Say we have this equation y prime is equal to xy plus 2x. Okay, so our notation here is in terms of prime, but we um, uh, can also use or transpose it in other notation, which is in terms of dy and its independent variable x, because we have x terms here. Okay, so we have dy over dx is equal to xy plus 2x. Okay, so this given differential equation here and this transposed differential equation here is just the same. So we have the derivative of y with respect to x and some functions of y and x here, that makes this equation a differential equation. Okay, so for our topic of separation of variables or separable equation, the first step once again is to try to separate the variable y's from x. So by doing that, we will gonna do some algebra here. So as you can see here, you can now have dy over dx is equal to, you can now separate this x here because they have both x terms. So we have x y plus 2, right? Okay, and then we can also multiply both sides by dx. Okay, dx, so we have dy is equal to x y plus 2 dx, and also to move these y terms here on the other side, we need to divide both sides by y plus 2. Okay, by doing that, we have dy all over y plus 2 is equal to um, x d of x. Okay, so this is now we can see now that our differential equation is separable because we can separate variable y's from variable x. Okay, and then once again our next step is to just integrate both sides. So by doing that, we have dy all over y plus 2 then is equal to the integral of x d of x. Okay, so we can see here that by integrating this dy, we have the ln of y plus 2, right? And then equal to the x squared, do not forget the denominator 2, and then our constant of integration c. Okay, so you can see here we've already come up with our general solution, but we can also simplify this by solving for y. Solve y. So how can we find the value of our y with some functions here? So since we have ln here, we can raise both all these terms by e. So by raising all terms by e, we have, right? So we have equation that looks like this, and e raised to ln is just y plus 2, then is equal to the e, since for simplification, our technique here is to do some algebra here in our e. So we can also say that e raised to x squared all over 2 times e raised to c is equal to this whole term here. Okay, okay, if you still can't figure this out, Then we may try to remember our algebra that say we have a raised to uh, a raised to n multiplied by a raised to m, then it is just the same with a raised to n plus m, right? Or say, for example, we have x raised to 2 multiplied by x raised to 3, so we have x raised to 2 plus 3. Or if we can combine this, since this is both numbers, then we have 2 plus 3 is just 5, x raised to 5. Okay, so by this principle, we can also say that this is equal to this, and this part here is this one, e raised to some n and m. Then we're gonna use this term a raised to n multiplied by a raised to m. That's why we have e raised to this part multiplied by e raised to this constant of integration c. Okay, because we can just simplify this further by saying that y plus 2 absolute value, do not forget, is equal to this term here, e raised to c, is just constant. So we can express this term is in just a letter c. So we have c e raised to x squared all over 2. Okay, or simplifying it further by having the value of y, so we have y is equal to, since this is absolute value, and then moving this positive 2 here on the right hand side, we have positive or negative 2 plus this part c e x squared all over 2. So this is now our general solution in terms of variable y. Okay, so our general solution here is y is equal to positive or negative 2 plus c e x squared all over 2. Okay, so that's all for this video. I hope you learned something. Once again, thank you very much for your time.